Hello, everyone. Welcome back, welcome back. Hi. More people may come in late, so please filter in. We're not completely packed today, but yet we're still like six. The wait list is still six big. So it looks like hopefully the class will be nearly full, but those who are on the wait list will probably get in. Welcome, come on in, have a seat. All right. Once again, welcome to ECS 179 Gameplay Programming. I'm Dr. Joshua McCoy. Please call me Josh. Maybe if we have time, I'll tell you the story why I go by first names and not honorifics, but we'll leave that as a bonus. Today, we're going to talk about game engines. Then, we're going to go over some things we didn't cover in the syllabus. I got a bevy of questions from, hey, when are the assignments due? And what exact details are there on the schedule? Well, we'll cover that today. Some things are floating just a little bit as this transition from Unity to Godot is uneven in its difficulty to map from one system to another across the projects. So where the instruction team is handling this so as gracefully as we can. Then we'll go over our Unity project. I'll show you a little bit of procedural art, and we'll go through the code and show you the project structure. And as a reminder, don't forget to go to the discussion tonight. It'll be a nice Q&A session. I'll show you some things in Godot, and we will learn a little more. And I'll go over what you need to know from the tutorials, from your assignment 0, to prepare for exercise 1. All right. Any questions that you don't think will be covered today? I have a question for you. Has anyone played UFO 50 yet? Oh, I was hoping more people would. Okay, I'm looking forward to UFO 50. All right. Tactical Breach Wizards? Right, that game looks really good. I have it queued up. I hear the story is quite compelling for its like tactical wizard, flat character, minimalist art nature. So just a couple things I'm stoked about, other than playing even more World of Warcraft and going to raid night after GDAC. Game Development Arts Club tonight. Okay, enough preamble. Let's get to the presentation. I do want to make a note that this is being recorded. This is why there are 2 microphones on the desk. One is for the room, one is for the recording. For technical reasons, these 2 systems are very hard to interoperate, so we're just doing both. We'll see how the audio quality turns out. It's been fine in other rooms. Luckily, this has a nice cardioid pattern. Okay, how many of you have tried to make your own game engine? Anyone been brave enough? Ooh, usually we have 1 or 2. Okay, I guess game engines are good enough now that people really don't need to. But this is a classic game programmer experience that you'll see here. I'm the master. This engine I am making is getting so powerful. It's so sexy and modular. It's a solid foundation for anything. And then the walker by comes along and just sees a square on the screen moving around. I'm sure you may have experienced that. You write this really cool thing, but it's in console or something. And so your parents just don't get it. They don't get how many hours you spent making the perfect data parser, or doing some really gnarly combinatorics to make sure that all parameters of a parameter space have been addressed, and doing all the debugging therein. Brutal grounding. That's unfortunately the life of the gameplay programmer, right? You get it into people's hands, play test early and often. You should make the gap between you and reality as small as possible. All right, so what is a game engine? So here are a few things. It's a 3D graphics library with support for animation, physics, and sound. What do you think? Is that a game engine? Is that a complete definition of what game engines are? Why is this wrong? Yeah.
Just 3D and not 2D.
Right? Already, we know, because we're using an engine that specializes in 2D development, Godot, for this class, that there's a flaw here. What else? Yeah?
Missing user interaction.
It is missing user interaction, right? That's very important. Anything else? Welcome, come on in, have a seat. We're running out of seats on the edge, so everyone please be kind and let people walk in front of you. Okay, how about this? A comprehensive game creation environment with an IDE tools and libraries. Is that a game engine? Does that encompass all game engines? What's wrong with this one? I'll give you a moment. You don't need a moment, go ahead.
Perhaps that can also run game.
I'm sorry? A little louder.
Perhaps run game in the game engine. Well, it's not just solely creation.
Right, running games in the game engine so you have a robust testing and debugging environment built in. Excellent. You could technically put that under tools. But there's, this may be a little too broad, right? There are things like Game Salad or Game Maker or RPG Maker that don't quite fit into this. Not every game engine has to be comprehensive. Okay, well, because that one had limitations, that one still had no user interface explicitly stated. What about all the software and hardware in your game that isn't particular to your game? Right? I think at this point we're getting a little absurd, right? So it turns out that defining what a game engine is quite tricky, which is why we're going to spend a few minutes unpacking today. We're going to unpack a spectrum of game engines and game engine-like things. Here is the spectrum we'll work with. We're going to go from lower level to higher level, from more specific to more abstract. Hardware. Games have certainly been written in hardware. Who knows the very first video game? Oh, close, close. It's very Pong-like.
I don't remember the title, but it was like some type of space game, like in the 60s or something.
Yeah, it's pretty close.
It was a tennis game, I think.
It was a tennis game. These two were contemporaries. You were almost right with Space War. But Tennis for Two was one of the first games. We'll have a video on it. We'll show you a little bit of it later. But it was all hardware. And the output, the display was an oscilloscope. It was quite clunky. Everything was mechanical switches. It was lovely. Operating systems, libraries, frameworks, game engines, makers, and wizards. So, whoops, okay, a little slow when I'm recording. Now we have all these various options here on this spectrum, all these various points of delineation. And I particularly chose these because they map well to things you already know as computer scientists. They map to known points of development, right? If there are genres for development, these are sort of like maybe platforms or high points within those, points of delineation. Hardware. I know this is a little bit of review. I'm just going to go through this pretty quickly. Hardware provides basic processing, memory, input, output. Usually deals with low-level programming. Sometimes you're in assembly. I think everyone in here has had to write assembly. Is that correct? Has anyone not had to write assembly? Nice. I'm glad you didn't have to. I mean, it's great. You should know it all, right? Arduino, arcade machines, pre-Xbox consoles. Game developers were creating in mostly assembly all the way up until Xbox. Isn't that wild? N64, GameCube. All these were PlayStation 1, some PlayStation 2 stuff. Almost all assembly. Some high-level language compiling down to assembly, but You were dealing with cartridges for the most part. Things like Arduino. How many of you played with Arduino, Raspberry Pis, these low-level hardware things where you actually have to deal with a lot of hardware concerns? Yeah, exactly. So making a game raw in Arduino is close to that. I mean, a lot of times there's an operating system, you put Linux on it or something, right? So the problem with this is your game's locked to the hardware itself. There's lots of fiddly management you have to do with memory, sometimes even registers. It makes the people who make processors in Minecraft look a little eccentric, right? You've all been there. Why recreate that with blocks? But I'm glad those people exist. Those artifacts are wonderful. So we have things like the Gameduino, which are hardware artifacts specific for making games. A whole 256 sprites. The luxury. Now, what do you think this is on the right? Anyone seen one of these before? This isn't just like a PCB generically. This is a very particular type of hardware. It comes in a really big case. Yeah. It is. This is an arcade cabinet game. I believe this is Street Fighter 2. I thought I pulled Street Fighter 2. You know, it's hard to tell. It doesn't say Street Fighter 2 anywhere on here. No, I'm sorry. This one isn't. This is, I see 1983 Nintendo of America. So this is a Nintendo arcade cabinet. This may be Donkey Kong. I thought I need to update my slide. I was hoping I would get the Street Fighter one. Okay, anyway, arcade cabinet. These were all hardware-based games. Everything in here was directly put onto a chip. There wasn't a lot of space for programming a binary and slipping it in. The hardware and the code and the software were very much tied. Operating systems. I'm sure you've all taken 150. And the joke is it takes 150 hours a week to get through that course, right? Provides file system. It gives you a more refined sense of input and output. You don't have to do like the entire stack of error correction, data retrieval, pre-processing before you can actually use the data. The operating system does that for you. Gives you even memory management. The luxury of malloc, right? Linux distributions, Windows, OS X, iOS, Android, Chrome OS. All these are operating systems. I'm sure all of you have used several of these by now. Is anyone running Linux as their main OS? Yeah, okay. I see where my people are. Here we are. I was a cluster administrator for a number of years before I went into academia. Very fun. So these are geared towards applications and not games, right? Operating systems give you everything from command line tools like grep, ls, awk, all the way through your window applications that are baseline for like Windows, like the settings manager, or adding in the dialogues for adding in and removing device drivers. You know, all of these are applications, not games. Microsoft Word, application, not a game. To make a game at this level, you have to manage a few things. One of the main ones that you use, and it's also in the Gameplay Programming Patterns book, is game loops, or the main loop. Right? You have to have something that accounts for time. How many of you have written an application on your own that accounts for time? Right? What did that look like? Can you give me a quick TLDR? Like what's the 3-line pseudocode or 2-line pseudocode for making a loop that handles time? That is durative, meaning it lasts. This is actually way easier than you think. All right. While true, do stuff. Or while not done as a Boolean variable, do stuff. Right? And then inside of the loop, that continuously goes. Eventually, you can handle input, you can do data transformations, you can render graphics, you can play sound. Eventually, you'll want to stop. Game will be over. The Q character will be detected from the input stream. And you'll set our control variable to false, and exit the loop. Game over. Right? But that's pretty low level, right? You don't have to do that in GitHub. You don't have to do that in Unity. You don't have to do that in Pico 8. Got people lurking. You can come on in. Come on in if you need. So this is the sort of sense of operating systems, right? Linux Mint is one that I've enjoyed previously in the last couple of years. Does anyone recognize the artifact, the computational artifact in the bottom right? We have a tentative hand. We got 2 tentative hands. Would either of you like to answer? Just feel free to shout it out.
You're talking about the game on the bottom?
Yeah, the game on the bottom right. Yeah.
I believe that's like an open source racing game that was made.
Oh yeah, this one's famous.
Was it like the
Every
Raspberry
Linux
Pi?
distro.
Does it run on the Raspberry Pi, or am I confusing that with something else?
It runs on every Linux distro that has the Windows system. That runs X11. Tux Racer. It's Tux Racer. Okay. I was expecting a little more Linux enthusiasm. Oh, I'm a little sad, but we'll get there. Libraries. These provide compartmentalized solutions, middleware in the game development vernacular. They have their own internal vernacular. All the function calls of the application programming interfaces, the API, inside of libraries are consistent with its own design. Well, if they're well designed. I've seen some APIs that are all over the place. But ones that are well used, well developed, typically have a nice use case within their own functionality, within the functions they provide, within the classes they provide, within their documentation. They have their own code standards typically. These are things like OpenGL or Vulkan, Fmod, TensorFlow. Anyone have a favorite library? Any library? Certainly you use libraries, right? Yeah.
3JS for web, like apps on. It's a graphics library for the web.
Yeah, I'm familiar with 3JS. I teach a class that uses processing, which is very similar. Yeah. WebGL, right? Have any of you used PyTorch? Library. The Twitter API? Yeah. These are used broadly. And what's great is they're abstracted from any particular hardware, right? Libraries are typically implemented on a variety of operating systems and hardware platforms. Things like, let's make sure we get the sound. I forgot to change the output to Crestron. Things like water simulators. I guess that isn't, okay, the preview on OBS doesn't like playing that very quickly. We'll let's just drag this over for just a sec. Nope, that's a full screen preview. Anyway, trust me, this is a cool looking set of physics simulations. See, there's blocks falling. I swear. I haven't paused. Okay, maybe I need a more powerful computer for this class. I have one on order. This will only be temporary. Right, so you can get cool things out of frameworks, or a lot of libraries. Now, frameworks are interesting, right? Because they are a set of integrated capabilities with a common interrelated vernacular. A bundle of libraries. .NET, WebTech, Ionic, DirectX, Pygame. How many of you have programmed at the frameworks level? This is a little more rare. Yeah, but which one? .NET? Which one? Oh, you use Pygame? Yeah, Pygame's neat. Yes. Yeah, DirectX. Oh, so you've done DirectX programming. How brave of you. Oh, okay.
Never again.
Never again. Is that a hand or? Okay. Right, so a common set of libraries, but this is still below what we think of game engines, right? Because there's no there's no specification for a game loop or game assets or library usage or the engine things that you typically associate with game engines, physics, graphics, sound, etc. Right? But you could make a game with this stuff, and people do, right? Particularly with Pygame. So Pygame is really just a set of existing libraries with a handy wrapper around it. I think it's a pretty neat little system. But a lot of people are familiar with Python now. Geez, that frame rate is really low. I apologize for that on the recording and for what you're seeing up here. My frame rate's like way better. I need to fix this. Okay. Now, with Pygame, you can make releasable games. People have made money releasing games made with Pygame, and that means they don't have the same affordances that you do with a modern engine, right? There's no importing of plugins, right? You have to deal with pip and setting Python infs, right? All the good stuff. You have to deal with classes in Python. Now, game engines. Come on. There we go. Game engines. Now, here's where we're getting a little more into what we see with Unity and what we are seeing with Godot. We provide a game-specific API and design features. Examples, Unity, Unreal. Oh, I put an A in Godot. As I phoneticize, I will fix that. Allegro, Creation, Frostbite, Essence, Source 2, the engine that ruined Dota or something, right? IdTech 1.7, IW, RenPy, Twine, Inform 7, many more. There are a ton of game engines out there in the world. Love 2D. Lots of open source game engines. People love making game engines just like people love making libraries. A lot of game engines don't see much use, but there's a lot of game engines that AAA games have been made with. Anyone care to venture why there's a proliferation of game engines that is now collapsing into Unity and Unreal? What's the chronology here? What's the game industry reason?
It's expensive.
It is expensive, so that is one of the reasons for the collapse. Good. What are reasons for the expansion? I see a tentative hand or two. Anyone brave? Yeah.
I feel like for a certain company, they might feel restricted by using someone else's game engine, so they're just gonna
Yeah. Each game genre type company has their own needs, right? That's definitely a reason for sure. Yeah.
Probably there's some that are specifically for specific genres, like RenPy, like visual novels specifically.
Yeah. RenPy is a good example. Although it's an open source one. An industry example would be probably a bespoke engine used by the rest in peace Telltale devs. A lot of this is secrecy, right? For a long time, particularly in late 90s, all the way through like the creation of like real strong versions of Unreal. Game engines were proprietary tech. They were the secret sauce. Hey, look, you had a game engine that could efficiently do normal mapping to show bullet holes in walls. That was a competitive advantage for a while, right? There's a whole world of game engines that we don't know a lot about. Sports games. Infamously secretive, particularly around their AI tech. Right, the announcer tech, the football behavior tree, or for soccer, both football in both senses. The behavior trees that run the agents on the field, that run the players. Right, there's a lot of stuff going on there, a lot of domain knowledge piped into usually behavior trees. But the details of those, the actual sensors mechanisms of inference, efficiency, how to quickly diagnose an entire field and infer what next steps you should take and how a tree should be handled with all the particularly live nodes on it. All that's proprietary. Take care. Right, so we're in a phase where these trade secrets are kind of becoming obsolete because a lot of people are figuring out how to do these things in the mainline engines. We're even in a place where we're switching a class on game engines to using an open source one because a lot of that knowledge is now available enough and reverse engineered enough that the public knows about it. And, these are made, the big difference between these and frameworks is these are made primarily for games and making games and genres. Right? And so a lot of game engines happened after a company made some bespoke games, 2 or 3 in a genre. Like, hey, we see some recurring implementation details. Or, hey, we don't want to write the whole thing from scratch again. Right? So this happens naturally. After you write a couple of similar things, you write many things in a genre. Which leads us to makers. Right? What these do is they provide a level of interactability which sort of removes the need for development. We're moving further away from the concerns of the technical concerns in a system. And we're moving more towards the abstract concerns or the game design and technical development, or I guess design meets development concerns. They have draggable elements. There's integrated editors with levels already built in as a primitive, with user interfaces built in as a primitive, dialogue boxes built in. And a lot of these, you don't need any programming. It's mouse only, right? You can type in like text fields and things, but most of it can be done drag and drop style. Examples: Game Maker, RPG Maker, FPS Maker, Game Salad, Click Team, Stencil, the Construct series. Have any of you used any of these? Yeah, a few. I just get a sense that a lot of people are kind of new to game development in general in the class. These are aimed at non-programmers, generally. Some of them have some API interfaces for you to do some more expansive things with. But here's an example of what Game Maker looks like. A few examples of what you can do with them. So this is Game Maker Studio. And you can see the user interface here looks a bit like you would see in Godot, but there's no code editor. There's no API to learn. All the things it can do are wrapped up in pre-existing node-like things that you then can combine and drag and drop into other things. But there's no way to make a new, whole new custom node in an efficient way. It's not made for that. You're made to design and develop within the bounds of what these makers do, not expand the bounds of what they do. Wizards. Wizards are interesting. They're more scripted, right? They lead you through the process of game development. They have pre-existing assets and content libraries. They have a preset list of game mechanics that you can use in various combinations. Right? You often see wizards, if you see elementary school kids making games, usually it's something like this, right? Where they play around with some graphics, some settings, do a little customization, and they pop out a game and all the games look very similar for the entire class. These are kind of fun, right? Because things like Games Factory out there. There are many non-video game wizards out there that make game-like things. Which Hogwarts house are you? Right? I'm sure you've seen a million of these, right? Instagram, Facebook, click on this link and take a small quiz to figure out which BuzzFeed-esque listicle item you are. There's a reason why these float around, because they're easy to make and people have fun with them. There's a clear set of steps that results in something playable. Right? There's many times I'll sit down to a game engine and make something that's not playable. But these, you get something guaranteed. As long as you persist through the entire wizard process, you'll get something you can share. And they often, if this is more of an advanced wizard, but you get a thing that kind of looks like, in this case, like a trebuchet game, kind of like an Angry Bird style physics smash game, where at best you can you can make levels and configure things within it. But typically you just get to pick the art pack and theme everything. Set some generalized parameters, rename things, that sort of deal. So we've been through the spectrum, right? And now I want to divide this up into some sense making, right? We went through and described some of these. This is like almost all of this should have been a little review for you. The top four here, hardware, operating systems, libraries, and frameworks, they're typically used to build engines. Frameworks, game engines, makers, and wizards are used to build games. Right? There's a breakdown here. There's an ontology that's meaningful. And this is typically how you should approach it, right? And frameworks is one of those interstitial spaces that is at one of those inflection points within a spectrum. And libraries, frameworks, and game engines are often reinvented. Maybe not by you. There didn't seem to be a lot of interest in making game engines here, maybe just using them. That's totally cool. It's probably a better place to be. But what's in your game engine? Well, it's really a bundle of technical solutions, languages, and practices. Right? In our conversation of design patterns, of the technical guts of what makes a game engine go, of the language specifications on how you interact with and program in a game engine environment. These are the some major pieces that you, as a gameplay programmer, will have to interact with. Things like, what are the base classes in your language? So, GameObject is a classic one. Node is the one for Godot. Componentized design, or compositional tree structures. There's typically scripting languages, some for designers, some for developers. And a scripting language has a few meanings, all the way from it is a language for the actual script and dialogue, all the way through it is how you use a domain-specific language, Python, Lua, Godot script, that interact with a larger computational system that give you a handy set of affordances to manipulate something sophisticated. And I often call these domain-specific languages because they end up being made for a purpose, and a lot of them are very elegant and designful. And I love some good scripting languages, some good domain-specific languages. Give me some answer set programming, it's a good day. There are data languages, object versus level descriptions, right? An ontology of how you see the world, how it is broken down and made manifest inside of your game engine. There's interoperability. Can your assets work in one format or another? Can you export your entire game into this platform or this platform? And then you have the language specifications for these scripting languages or whatever language you interface with. And there's a lot of computer science topics here. Programming languages, compilers, generics, optimization, graphics, now more and more artificial intelligence. All the way from machine learning to the other 95% of artificial intelligence techniques. A lot of stuff here. And then it's a set of human practices, right? A game engine without a game developer or a game designer is something that makes barely playable things typically. Now, a lot of people will learn on the fly and develop some design chops just by being with the system, and that's great. But how do you create and integrate content? How do you combine a bunch of nodes and GD scripts together to make something cool? How do you plan to make a larger thing in one of these environments? Then how do you build and enact that plan? Then how do you debug the inevitable things that go wrong? And then how do you deploy it to systems? Right, all of these are practices, right, that rely on computer science topics such as software engineering, human-computer interaction, mobile design. Is the mobile design class offered this year? I haven't looked. I guess no. All right, so what's at risk, right? So good engines solve problems for you, but they also enhance your ability to create. Bad engines get in your way or create problems, right? And it's not just bad engines, it could be the wrong engine for your task. You could pick a very capable engine. You could pick, like, if you're not a savvy developer, you could pick Unity, but really what you want to make that platformer was GameMaker. So a bit of advice, use or create the tool that's right for the job. You know, and a lot of solutions may look non-traditional, and traditional solutions may not be correct for you. Like if you want to make a visual novel, you don't need Unreal, you need RenPy. But we are learning a more generic game engine in this class, so you can be prepared for a few more genres and learn a more full-strength version. So I know all these slides are available for you, but here are some related works of some interesting research done in this space. Are game engines software frameworks? A three-perspective study from the Journal of Systems and Software. We have the game engines overviewed article from the Communications to the ACM in 2002, back when they were a little more novel computer science artifacts, and they were being studied in conferences, in computer science conferences. A taxonomy of game engines and the tools that drive the industry. This is from DIGRA, the Digital Games Research Association. This was a cool conference in Kyoto. This is a really core games and game studies venue that both technical game scholars and folks from like English departments and studies departments go to. So that one's a very interesting one. How BioWare's Anthem Went Wrong by Jason Schreier. Can you follow Jason Schreier? Pretty prominent game journalist. I recommend the Triple Click podcast. It's pretty cool. Back when they were at Kotaku. And then Building a Game Engine, a tale of modern model-driven design. So this was from the GAS workshop, which is a pretty well-known software engineering or software engineering workshop. All right. So any questions about engines? Anything you want a little more elucidation over? Yeah.
When you were deciding between like game engines for this class,
Mm-hmm.
you brought up like GameMaker several times now. Why didn't you go with GameMaker over Godot?
Because you're computer scientists and you can nail the programming, and we can do a lot more with it. And I want this class to be about the software engineering and design practices, and you don't get that in GameMaker.
GameMaker has like a coding thing you can do like scripts and programming in it.
Yeah, it's much lighter though than what we can do with Godot and Unity. I want us to be able to expand and maybe even do procedural graphics, that sort of thing. Good question. All right. Yes. I didn't quite understand what the question was. Was the statement?
So the difference between game engine and the game maker is that we still need to write programs basically.
Yeah, the difference between a game engine and a game maker is about the programming interface. There's a lot more programming in game engines than your typical game makers. But a lot of it is the limit of the design sphere around the maker. What does the application do for you? Right? If it is doing significant things for you and is less expandable, then it's usually a maker. Right? So for instance, Game Maker, you have a lot of preset, interesting like sets of nodes and things, right? But Godot is made so that you can easily construct your own scenes and make your own nodes and prototypes. So you can work at a level of abstraction that Game Maker typically doesn't afford. And it may be moving more towards a game engine, right? This often happens with scope creep. And particularly very popular ones like Game Maker may be expanding their capabilities over the years. And who knows? Maybe in the near future, we may consider an engine instead of a maker. It's a spectrum, right? Let's dig. Into the syllabus a little. Good. All right, so a few things I wanted to go over that we didn't quite get to go over last time. So we went over all the basic information. We have a TA. One of our TAs for the course is Nick Trainer. You can see him waving in the back. Hi, Nick. If you want to introduce yourself, that's totally good, but you don't have to right now. Yeah, sounds good. Didn't mean to bring it on. And we will have another TA for the class as well. It's still a little up in the air who that is. But we have Harpreet Sandhu, who will at least be making assignment 1 for us, helping me refit it. So at least I want to credit him for the contribution. All right, I need to update this one here. I forgot to push that to the course. All right, so here is the grade point thresholds. Notice there is no A+ here. I reserve A+s for those who really impress me. I usually give out 1 or 2 a year. So if you get an A+, you know, I know how to write you a letter of recommendation. Right? We talked about exercises. Let's look a little bit at the schedule. All right, so notice their readings. These are enrichment readings. They are meant to pair well with what we're doing in class. But typically, I've designed it so that you have enough out-of-class work that the readings would push you over the Carnegie limit for the class. But for those of you who are more serious about games and game development, I encourage you to do the readings. And you can find the readings in Canvas, like the ones that are more protected. Copyright, full, if we have deals with the library or whatever, you can see them in Canvas. We also have a list of topics, the readings, discussion plan. So a lot of this we'll refactor just a little bit. So this will be roughly accurate, but some of the details may change. And the assignment, getting started with Godot materials is sort of like your assignment for this week. I know it's a little weird because we had a half week at the beginning, but the idea here is that you will get an assignment starting next week, or maybe at the end of this week. We're going to see if it actually gets done in time. You'll get an assignment Thursday, Friday, or Monday. I will send out an announcement and give you all details. It's almost done. But I want to make sure it's more rock solid. I want to test it a little bit before I give it to you. You are not beta testers. So although I'm sure it won't be perfect, I want to make sure there's something like really usable for you. So the idea here is that you'll get an assignment. Let's say you get an assignment on Friday. Assignment on Friday. It will be due the following Friday. Your technical solution for that assignment will be due the following Friday. We will then, hopefully in that same day, add you to someone else's repository. And then you will have until that next Friday. Friday 1 assignment due, Friday 1 assignment assigned, Friday 2 assignment due, and peer review assigned, Friday 3 peer review due. Each assignment will have that cadence, that 2-week cycle. And the peer reviews are much lighter to do. Code reviews of someone else's project reviews are much lighter to do than the actual assignments themselves, right? So this is why we're going to build a little pipeline. So give it exercise 1. Next week, exercise 1 implementation is due, but exercise 2 is assigned, right? So once we fill this pipeline, you will be working on an assignment, technical implementation, and the previous assignment's code review in the same week. And we'll likely have 3, maybe 4 assignments. I think I get enough assessment detail and you get enough experience to do 3 assignments that the 4 may be a little superfluous. I want to see how you're all doing though before I make that judgment. I would really, if you're all doing really well, I'd like there to be 1 less assignment so you can have that much more time working on your final project. That's sort of the real goal of the course. All right. And all these will be on GitHub Classroom, so you'll be using your Git knowledge to turn in your assignments. They will be, there'll be clear instructions on that. You can see a lot of things, including up here in the materials for the course. You see other things like peer reviews. Right, and these were last year's, and we're updating for this year. Examples of good reviews, bad reviews, and the grades that those were given. And then we have the templates for each one of these. So when we talk about peer reviews, we're going to go over these in more detail, so you can see what these look like. But if you wanted to get an early start and see what our sort of grading rubric and scheme is like, because it's reviews, it's a little fuzzy. It's very hard to put fine point details on a lot of these. It's almost more like grading an essay than it is grading a math proof or something. So feel free to check those out. Back to it. And we'll see how you're doing on assignments. I really don't like giving quizzes or exams, but if the knowledge needs to get across or if attendance gets super low, I'm going to need some way of assessing people. So those may be there. So we do have 4 exercises assigned and designed. There's a utility in only doing 3 but having 4 available. Perhaps you kind of botch exercise 2. Well, there's an exercise 4 out there we can give you if you want to take another shot at a different project. Right. So I'm pretty flexible with this. As long as we have the TA resources and grading capability available, I like to provide as much chance for recovery as possible for you all. That being said, deadlines still matter because there's 120 of you, and there's a TA team of 3 people. Right, so that's a lot of work. So we just have to keep the ship going a little bit, but exteending circumstances is all right. So notice that this due date is a little lighter on week 6, 7, 8, 9. We'll be filling these in with progress reports, our discussion sections. Towards the end, we'll turn into group check-ins, and we'll give you the ability to talk with us and talk with your groups. Typically, what we do is have you break up into your groups in the discussion section area, and we go around. That worked a little better when discussion was set up, was more split. I want to see what the room is like and see what we can do. Otherwise, we tend to do a lot of media exploration in this too. Like we play some games on typically the last lecture of the week, and we discuss them and talk about how we would implement some of their designs. We may push that perhaps to discussion sections if there is not an amenable place for us to do our group check-ins. And what we'll do towards the end is, and this worked really well last quarter, we got a lot of really good feedback on this, is you're not just working with your team, but there are 2 sets of progress reports where your progress report is actually written by another team. And so you have to show them what you've done, give them a little tour, and then I have a templated document that you will fill out for another team to review their progress. Right, and that makes it a little less onerous. But then you also get to form like these little triads of groups. And we try to put people's games and genres that are like together so you can talk across and build a little community outside of your original group. MMORPG, right? All right, so the topics, this week we're giving an overview, game engines. We'll talk about the command pattern. We will give some examples of things we do in Godot this week. Then we'll talk more about Godot structures, code standards, and best practices. Maybe even this week, maybe get started on some of those. Talk about style guides, camera systems, linear interpolation, common game techniques, common like zeroth level gameplay programmer skills. Particularly, this is one of my favorite things. I really like this scroll back to theory and practices of cameras and side scrollers. I know I like this one, so I use it in game platforms as well. Then we're going to talk about game mechanics, game events. We're going to talk about the observer pattern. We're going to talk about data-driven systems, hopefully. I've not been happy with the lecture for that one, and I want to revise it. I may cut it for something else. More will come. Then mechanics, rules, gameplay systems, component systems. So we're going to start deepening our knowledge of what constituent game parts are, from a more technical to, now that we have a technical basis to implement actual things, to what those actual things are, and build a larger, more comprehensive knowledge base. Then we'll talk about interactivity and do things with the factory pattern. And that will be an extra credit exercise where you'll make Magitech spell factories in groups for extra credit if you'd like. That one's always a fun. It's good times. Then we're going to talk about game combat algorithms. We may go deep into Final Fantasy VI or 4's combat algorithms. Look at some of the bugs. We can go through a game fac and see actually how damage is calculated based on strength, armor, equipment, enemy resistance, that sort of thing. That's where I like to live. Then we'll talk about game design documents, because you'll be, at that point, really thinking about your own. Then we're going to spend an entire week on The Jump. The Jump from Super Mario Brothers, and why it was sort of revolutionary. And we'll cash that out in pretty deep ways, and then we'll talk about building a physics system with an eye on jumping. We'll look at some of the calculus behind what's actually going on and how you can be more formal and more precise in your ability to do game motion. Then I really like doing a segment on procedural content generation, and then artificial intelligence for games, which is a little different than the modern conception of artificial intelligence. Although the worlds are converging. And these last ones, they change often, so I tend to give the readings for those closer to the actual lecture when I modernize the slides and lectures. Every year, a renewal process. All right. Any questions about the timeline? About the scheduled things in the course? I know this class is right after lunch, right? Yeah. Yes. Well, because I haven't put the office hours up yet. I just scheduled my lab meeting so I can schedule office hours. I will definitely hold some tomorrow. I will probably hold them at 4, from 4 to 5, and then we'll see how it goes. I want to give you a chance to interface with me for learning Godot and getting ready. And I'll record that session, and we can post it. It'll probably just be on Discord. That would make it a little easier, I think, for folks to handle. You want to come to my office, because it's going to be like 102. What sort of October is this? It's ridiculous, right? Global what? All right. So that's the plan, and I will likely have my office hours be set around then, or maybe a little earlier on Wednesdays. We'll also have TA office hours. I need to contact the CS Tutor Club. Do we have anyone in here that's a CS tutor in this class? You've been a tutor? I know some of the tutors have taken this class before. We had some tutors that took a lot of our games classes. Some of them were very excellent for this. But I want to interface with them and get some additional help for you as well, if possible. I'm also going to bring some alumni in, and some people who previously talked about this class and talked about their games and their implementations. We've had some really successful game artists come through our games programs here, and people that work for Unity, people that work for NVIDIA, people that make games in arts and independent circles have all come through this program and have taken this class. So we have a nice, rich set of folks for you to talk to and frankly network with, right? So if you do well in this class, I will probably be pestering you to come and interface with it or the folks in there at some point. Cycles of alumni interaction are good things for you. Okay, I'll blather on about that a bit. Things we didn't get a chance to talk about. Who's this? Nobody know this? Legendary character. I know it's getting along in the tooth. This game has its 20th anniversary November. Like this game's older than some of you. This is Illidan Stormrage from World of Warcraft. And his catchphrase, the big tagline, one of the more known quotes from the entire franchise is, "You are not prepared." Right, so this is why that's the tagline. I had a set of small C# game development demos. You can still play these. You can still test these out. Little Final Fantasy themed tech demos made in a .NET language, so you're running C# in the browser. And there was a Unity exam I had for really non-technical games master students about Unity that you can look at. I didn't remove these completely. I just struck them out so you could still play with them if you want, but no, they're not 100% relevant to the class. And so we are preparing for projects. How many of you have started watching the videos? Good. What do you think? This is the first time I put a set of materials together for Godot. They good? You like them? Brackies? Yeah, everybody likes brackies. I tried to pick the best stuff, right? I tried to pick a good range as well. There's just so many videos to go through out there. And I know a lot of you really like learning through videos. So try to support. How many of you have read any of the books? Maybe one or two. I spent a lot of time finding those. It's cool, it's cool. They're there for you as references. Right, and these are some general notes. I actually want to spend some time before our discussion section today. Hopefully I have some time to put together a Google Doc, which is a little more comprehensive on the actual things I think you should know, more specifically for getting through this assignment 0. I'm going to scaffold this just a little more for you, okay? Here's a set of materials on Godot, including the actual game engine documentation and the Godot's Getting Started tutorials. And I picked out some highlights from inside the doc because it's pretty huge. Things like the introduction to the actual editor and what it looks like and feels like. Troubleshooting if the editor doesn't work for you. Right? It's like very baseline. Hey, Godot doesn't work for me, professor. How do we get it to work? That covers some of the more common cases. Nodes and scenes, which are a basic capability of Godot. Instances, because it's still an object-oriented system at the heart. A GVScript reference, the actual language reference. I haven't found the BNF for it, or the language grammar for GVScript. If any of you find it, shoot it to me. I want to put it in the syllabus. The best practices. A set of 2D and 3D capabilities. We'll be doing a little bit of 3D in this class, but we're going to stick mostly to 2D since it's a little easier to bootstrap, and Godot is a little more capable in 2D. Animation tools, and an asset pipeline. I'll probably put some docs in here about exporting. And here are the additional texts. You can look over those. These are also listed, just like the videos are, of more general to a little more advanced. And then down here is, I think, some really interesting stuff. You know, all this is optional, but I've been collecting a lot of game design, game development resources over the years, and just these are a little bit of the highlights. There's a small look into my bespoke liquor cabinet of cool things. Fallout, postmortem on Fallout. Postmortem on Deus Ex. Postmortems are actually some of the more interesting ways to learn about what developers were thinking. Kane, Spectre, Mirabello, right? All these are pretty well-known designers. And then talking about design documents, And a lot of this starts out as more design general, and then moves into the actual crafting of game design documents. So the core of a game by Brenda Romero, followed up by a feature set from the core, followed up by creating a game design document. So a little trio of Brenda Romero, previously whose main name is Brenda Brathwaite, who you may know for games like Train or Raven Train, who is a partner to John Romero, who made anyone? The legendary game? Doom. Doom 2 in software with Johnny Carmack, right? So, storied game developer. Excellent articles. These were recommendations from her directly when she was at Santa Cruz. One-page design documents by Still in the Brandy. We're going to go deep into this. This will be a lecture that we have. This is a lecture I love to give because it brings a lot of varied interests together, from graphic design to technical design to presenting those designs to a technical team. All of it's in there, and that DHAC, the Diablo 3 proto document that we looked at, that's one small snippet from this lecture. And these are some design templates for you to use if you'd like. Game feel. Flambeer, the art of the screen shake. This is a pretty legendary talk that sort of like really shook up the indie game space and pushed the conversation around the small elements of games and game interaction to the next level. So making a game like feel good to feel juicy. This talk really put a fine point on it. And it was followed up by, sort of conceptually followed up by Juice It or Lose It. And there's a few games in this genre. So I actually have a backup assignment in case I have to go out of town or I'm sick or something. A take-home study session that is about game juice. Production cycles, 4 phases of game development. I'm probably going to add a link to Tracy Fulton's game design workshop in here. What happened? Okay. How long has that been? Camera's gone. Let's see if that'll. Webcam gone. I was trying to keep my face on there for the videos. Now it's gone forever. Now we're back a little bit. Okay, let's cross our fingers. You know what we're going to do? We're going to take this. Sources. Now I'm trying to and we're watch this. Be able to watch it or you can go to the web page and follow along with what I'm saying. It'd be fairly easy to follow. Project version control. I'm going to have some basics here. Social things clash should be looked at. If some media from the background, make it just ask first. Things wide, but it is connected on the class and on the Discord names to the actual directions. We'll start this something up. Like, cool. People point at my son and laugh. So any questions about this before we look at a? Okay. Stop the recording and just. I'm everything unless we can put that fit. Projector strong. We'll just yes. Should go down. for you. Each film. Fine. House of moving, I'm not touching it. This is called it is in the gallery. Right. Okay, let's look at per lookers. What is it? Yeah, okay, actually, so now I have played real face for so we're gonna, I'd love you project. Maybe eventually you have so we are the basis script jobs and adds up to that. The start of the project. The origin is bringing we have which is a conditional mesh. A block 16, so that is a through which we see the world. It has some on like so you know just the or